Oil is the fuel source for most of today's cars. Crude oil is a fossil fuel. Fossil fuels are formed from plant and animal decay from seabeds that existed millions of years ago. Crude oil is made up of hundreds of different kinds of hydrocarbons, which are molecules that contain hydrogen and carbon. The hydrocarbons must be separated in order to make something useful out of oil, and this is where oil refinement comes in. Here at the factory, the oil refinement process takes place. During the process, the oil is separated into fractions. Then the fractions are processed into gasoline. Finally, the fractions are combined to make mixtures that result in different products.
Biodiesel.
Here tonight on GNN, we're with Sarah Pellin to talk about biodiesel. Now Sarah, what are other countries doing in the biodiesel field?
Argentina's biodiesel industries are booming as a result of domestic demand along with strong export markets. Almost all major players in Argentina's vegetable oil industry own or are constructing biodiesel plants. In India, biodiesel is now being produced locally for use in stationary engines and large or slow engines like those in trains, trucks, and tractors.
What should the US be doing in the biodiesel field?
If biodiesel is to become an effective instrument for energy and environmental improvement, more efforts should be focused on creating the scientific and technological breakthroughs necessary to allow advanced biodiesels to compete.
Is biodiesel from waste plant materials economically attractive?
Yes and no, because it provides jobs to farmers, but at the same time, if the demand for corn and other organic materials increases, then the prices go up for the other products that need those same resources.
What chemistry technological development programs should be supported to enhance the advantages and reduce the problems associated with biodiesel?
Well, the Appalachian State University is conducting a collaborative biodiesel project where their goal is to create a sustainable biodiesel processor model that can be easily replicated by others.
What is the status of biodiesel technology?
Well, scientists have figured out how to make biodiesel that is capable and proficient, but are looking to sustainably produce a biodiesel that does not use a huge portion of the cropland that is critically needed to produce food and feed. It is necessary to explore alternative feedstocks for biodiesel production.
Here are the benefits and the challenges of biofuels compared to fossil fuels.
The benefits.
Fossil fuels give off toxic emissions called greenhouse gases which trap sun rays in our atmosphere, causing global warming. Biofuels do not release as much carbon as fossil fuels do, so there are fewer harmful emissions.
Being made from organic materials and even organic waste, there is practically an infinite amount of biofuels available because it can be grown. Biofuels are made out of organic substances which are biodegradable. These fuels are much less toxic in the event that something happens, like the oil spills that occur. If these spills were biofuels such as biodiesel, they would break down naturally, and the environment would not be affected nearly as much.
What are the challenges of biofuels?
A wholesale societal shift from gasoline to biofuels, given the number of gas-only cars already on the road and the lack of ethanol or biodiesel pumps at existing filling stations, would take some time. Also, it is a challenge of growing enough crops to meet the demand for biodiesel, something that might require converting almost all of the world's remaining forests and open spaces over to agricultural land.
Another challenge of biofuels is whether producing them actually requires more energy than they can generate. A study found that producing biodiesel from corn required 29% more energy than the end product itself is capable of generating.
Ethanol is derived from corn, then blended into gasoline. It can be added to petrol to be used as fuel. It makes petrol burn more efficiently and cleanly. There's some conflict about the production of ethanol. According to scientists, more oil is actually burned to make ethanol than what is produced, causing us to lose more money. It's also driving up the costs of food because so many cornfields are used for ethanol. By raising the price of corn, they raise the costs of food overall. The government spends $1.4 billion every year on ethanol production. It should reduce greenhouse gas emissions and help reduce American dependence on Middle Eastern oil. An acre of U.S. corn can be processed into about 328 gallons of ethanol, but planting, growing, and harvesting that much corn requires about 140 gallons of fossil fuels, and it costs $347 per acre. That is $1.05 per gallon of ethanol before the corn even moves off the farm. Overall, ethanol from corn costs about $1.74 per gallon to produce. Petrol only costs 95 cents to produce. Corn production in the U.S. erodes soil about 12 times faster than the soil can be reformed, and irrigating corn drains underwater aquifers faster than they are being replenished.
You mean to tell me methyl tertiary butyl ether was detected in our water? I am banning this chemical. I don't like ethanol.
Yes, but in 2006, CO2 emissions had reduced by about 8 million tons, which is like removing 1.2 million cars. And standard ethanol releases 80% less carcinogens into the air than unleaded gasoline. Finally, leftover corn can be used to feed livestock.
Yes, but making ethanol requires both nitrogen and natural gas to make it. And the large amount of area used up by corn will leave less area for other crops. Also, corn-fed animal meat has less nutrients than grass-fed. Finally, producing ethanol requires 29% more energy than what the end product can produce.
Fine, let's look at the chemical reactions of how ethanol is produced.